Hi, Amit here. Welcome back to my channel. In today's video, I'm going to go through the process of setting up a fresh install of Ubuntu 22 on a physical PC. So Ubuntu's already been installed, but I'll go through the process of installing LXD or LXD. Then I will download some scripts from my GitHub repository to enable me to automatically create free virtual machines based on QEMU KVM. And then I'm going to use MicroK8s or MicroKubernetes. So I'll be setting all of that up on a brand new install of Ubuntu 22. So I'll get back to you after the intro. We are now ready to get started. So I'm logged into my fresh install of Ubuntu via remote desktop, and there will be a few bits of there'll be a few tasks I need to carry out to get this working. A few months ago, back in August, I actually went through the process of setting up a Kubernetes cluster across 3 virtual machines on a physical Ubuntu machine, and I followed some steps from this website, which I'll just bring up now, which is this one. And these steps worked. I got it up and running. It's a little bit complicated, and so I'm at the start. I'm at the process where I'm looking to learn Kubernetes and get a lot more hands-on with it. So I was looking at possible ways of learning it more quickly. So I was looking at Minikube, which didn't really work out for me. Then I was looking at a tool called MicroK8s or MicroKubernetes, which is by Canonical. It's not Kubernetes, but according to this website, it's the best Kubernetes experience for developer, DevOps, cloud, and the edge. So yeah, I'll be taking a look at this over the last couple of days. So I'll be setting this up in this video and showing you how it works. And there's a really good tutorial which I'll post in the description box below. So I'll get started. So I'm going to go back to my remote desktop, which is that one, and I believe I've also set up SSH on this as well before recording this video. So I'll just quickly check to see it's running. It is, and I will log into it via SSH. So, and it looks like just going to log into it via SSH. Okay, I did also make the necessary steps of performing the updates that were required. I also deleted the known host entry from the known host file in the SSH profile to allow me to log back in. And I'm just going to go back to my notes for setting this up. So, okay, so I will set up some packages. I think I've got Git already installed, so I think I've already gone through the process of setting up Git. I'll do that. Yep, and I think I've also gone through the process of setting up Python 3 and Python Virtual Env. So what I will do is just download my code from GitHub. So let's do that now. And paste it in there, like so. Go into bin. Just enable virtual env. Okay. there's a typo there. Let's try that again. Right. So we're now inside a Python virtual environment. I'm going to install some Python modules using pip3. So this will be toml, psutil, and flask. Okay, I might have misspelled. Yeah, there's a typo again. So try that again. Okay. Looks like they're installed. Just going to clear the screen. Okay, so my notes are saying to open another terminal, which I won't do because I do have a front end which looks at my lab when it's up and running, but I won't show you that just yet. I will just go through the process of creating the virtual machines for the cluster. So let's have a look. So the next thing I need to do is install LXD or LXD, which is not currently installed, so I'm just going to install it now. Okay. So LXD is installed. Just going to quickly run neo fetch, another tool I installed just after, which I normally install, so I'm just going to install that as well. A lot of typos for me today. Just going to run neo fetch. Okay, yeah, so this will show you some information about the machine I'm on. So it's a physical install. Got about 64 gig of RAM. It's a Ryzen 9 5900 HX processor with 8 cores, 2 threads per core. It's a B-Link GTR5. Okay, and I'm just going to run a tool called Glances. And that's showing a lot of information, so you can see its CPU usage. On the top right you can see its uptime, load, average, the number of cores, and on the bottom left I also keep an eye on the temperature as well, so it's currently running at 30 degrees Celsius. So I'll just quit out of that, and those are my scripts. Now we're just going to run LXD init to set up LXD, and this is going to be a one host or one node LXD. Well, it's just going to be one node. I won't be using clustering for this particular example, so note that. The rest of them are going to be set to default. I will not be using IPv6 for this example. Okay, so if I do LXCLS, we don't have anything up and running just yet. So I'm now going to create the virtual machines, and for each virtual machine, MicroK8s will be installed as well. So I'm just going to run the time command, and this is the script I used in my previous video as well to create those machines. So just going to run that. And these will actually be virtual machines, not containers, based on QEMU KVM. and I anticipate this process will take about 10 minutes to run. I've actually put in some sleep statements in the code to avoid overloading the hardware. So while that's running, let me see if I can connect to VS Code on this machine. Just waiting for VS Code to connect. I'll just bring that across. Okay, so here's VS Code. It's connected to the machine. I'm just going to take a look at, yeah, so it's currently running this. I'm just going to install a Python extension as well because it's a brand new install on the Ubuntu machine. So yeah, so it'll create the instance. It's going to read from a toml file. So let's have a look. So I've defined the virtual machines in this file here that it's creating. So we have the controller node here. All 3 virtual machines will be running Ubuntu 22. For the controller node, I've allocated 8 GB of RAM, 6 CPU cores, and for each of the 2 worker nodes, 4 GB of RAM, 4 CPU cores, and I've set them to type VM. So when the logic will be looking at the toml file and it'll be creating those resources, and then going further down, we'll check to see. I've got a little check to see if the health is okay, and if the health is okay, it will go ahead and perform further configuration on those instances, including installing MicroK8s. So at this moment in time, I've got a short-term workaround, but I'll be looking to put in a more elegant solution in future. So the workaround is to use Lexi file push to copy a shell script across to each of the machines and run that script, which is, this is the shell script, to be honest with you. So it works at this moment in time. Going forward, I look for a much better solution. So I'll go back to the actual terminal and see what it's doing. So yeah, it's still going through the process of creating each of the instances, copying the script across and running the script to install MicroK8s. So what I would do is I'll speed this part of the video up and get back to you once all 3 VMs are up and running with MicroK8s installed. The 3 virtual machines have now been created and MicroK8s has been set up, or sorry, has been installed on them. So the next part is to log into each of them and go through the crib sheet. So bear with me, let's do that. Okay, so the script that was run just now would have done the install of MicroK8s. It would have carried out these steps as well. And I'm just going to go from this process here. So what I'll do is log into the first machine. So exe shell, the name of the controller. If I type in okay, so we basically got one node in that cluster. Okay, so actually what I'm going to do is I'm going to move this script sheet to another monitor, and I'll be carrying out this work in VS Code, which for me would be a lot easier. So let me just, as per how I set up the actual Kubernetes cluster in the previous video, so I'm just move the crib sheet across. Okay, this for me would be a lot easier to follow. Let's bring up my OBS window and my other monitor as well, just to make sure that can be seen. So let's zoom in a little. Okay. Just gonna give myself a little bit more real estate, just make that bigger. And I'm just gonna split the terminal into three for each of the three nodes. Right, that across the left. I'll do alias. So I just want to open up a shell on each of the three VMs. So open up my crib sheet on my main monitor. Right, so we've got one node. If I'm just going to run get services, Kubernetes as a service itself. I'm going to run this command to show everything that's currently running. Okay, it looks a little bit messy. So what we've got is this literally shows me everything what's currently going on. So some of the built-in services such as core DNS, the controllers, Calico, which is used for the networking aspects, from what I was reading the last couple of days. We haven't deployed any apps just yet, so what I'm going to do is I'm actually going to add the other two nodes to the cluster just to get started. Okay, let's do that now. So So the main controller node, it's MicroK8s, add node, and it gives us some commands we can actually run on the other nodes to join the cluster. So I'm going to paste, so we can actually join the cluster as additional controller nodes, or we can join them as worker nodes. So from my understanding is a worker node would be a lot more lightweight than the actual controller node itself. Bearing in mind I'm actually running these 3 VMs on a one physical machine. I will make the other 2 nodes worker nodes. So I'm just going to paste that one in as so, and it's just waiting to connect to the cluster. And if all goes well, it should join the cluster after a couple of minutes. Then on the controller node, if I run the get nodes command, we can see we now have 2 nodes in that cluster. I'm now going to join the second worker node to the cluster, and just to make that easier to see, this is the command, MicroK8s join, then the actual command. So it's the IP address, port number, token. So let's grab that and put that in there. And then we're just going to look at the nodes. So there you can see we now have all 3 nodes in the cluster. I'm actually going to log out the other 2 virtual machines. Don't need to be in them anymore. And we'll just have one terminal session for the controller node. So what we're going to do is we are actually going to deploy our first application, and we're going to deploy out of the box test nginx application. So just do that now. Okay, so before I can run that command, I actually need to deploy it first. So I'll try that again. So it's created it. Then I run the previous command, which I put and it's showing that we have that sample web app up and running. And it's currently running with 1 pod. So which I'll explain very shortly what that is. So if I show everything using the MicroK8s kubectl get all namespaces -a wide command, this will show in more detail what's going on. So we've created a new sample web app here. It's ready. It's running on 1 actual pod. Now, from my understanding, a pod is the smallest compute unit in a micro Kubernetes or Kubernetes cluster, and it could consist of 1 or more containers running. I understand it's using containerd as its runtime. Previously, Kubernetes in the past has used Docker as a container for its container runtime. So that's running. So this is the pod. The actual pod itself is, so we have 1 pod allocated to it, and the actual pod is running on this virtual machine here, this one here. And we can actually scale this app up and down according to our needs. So I'm just going to go through the process. So the next command is we're going to scale this up. So we're going to go from 1 pod to maybe 12. And then I will run that previous command again to show everything. And so it's actually started to scale the application up, and it's in the process of creating the relevant containers for those pods. And we can see some of them have been created, and we can see that they are getting spread across the different virtual machines. So some of those pods for that test web app are in the controller node, and some of them are in the other 2 worker nodes, as you can see there. Okay, so the default web app has been deployed. It's running across multiple pods, which themselves are spread across the 3 virtual machines. So we're going to describe the app. So these are the actual endpoints for the app. Okay, and so I can do a curl command. Let me try a curl command against one of those endpoints. And we can see, yeah, we can see it's running. And yeah, so we can see it's running. Okay, so this is my first actual look at. This is actually my first actual look at looking at MicroK8s to help me get more familiar with Kubernetes technology this weekend, and I thought I'd also record a video of how this looks, and I'm in the process of trying to automate setting this up as well, so it will save me a lot of time in future. The main driver for this is to learn Kubernetes technology. So the first step I had at setting up a Kubernetes cluster, it worked for me, and I was able to replicate those steps, but each time I wanted to create a cluster, that process would take me an hour. So using MicroK8s and has cut down the process from taking 1 hour of my time to about 10 hours of my time for actually creating the 3 virtual machines and setting up the relevant libraries. The actual part of adding the nodes to the cluster and doing the deployment of the test application is still manual, so I'll be looking into what I need to learn to get past that, I guess. So and I'll be doing a lot more research into that going forward. I'm also looking at learning other technologies such as Terraform, which is what I've also been looking into, and I'll see what I can do, what other technology I can use alongside MicroK8s and or Kubernetes to help speed things up. Anyway, so this isn't a tutorial video as such, not even a real demo, because it's not very slick. It's just me showing where I'm currently at in this journey of learning Kubernetes technology. So that's about it from me at this moment in time. Thank you very much if you got to the end of this video. Please feel free to subscribe to my channel should you wish to see further content from myself. Please do not forget to hit the notification bell should you wish to be notified when I do upload further videos in future, and thank you so much again.